two chords are congruent if and only if, and you're like, what the heck is a chord? Aiden, stop. So a chord is like a diameter, but it actually does not go through the center. So a chord is line AB and line CD. Those go through the circle, but they are not a diameter, so they're called chords. An arc is the outside of the circle like we were doing yesterday. So two chords are congruent if and only if the arcs are congruent. So basically, if you know that the arc, so AB as in an arc, is equal to arc CD, and those are not straight lines, those are curved lines. So if I know the arc on the outside of the circle, let's say is like 100 degrees, and this one's also 100 degrees, if the arcs are congruent, then the chords are congruent. So I could say AB, the line AB, is also equal to the line CD. And it's confusing to people. Like earlier, they were confused because they're like, the letters are the same. This is an arc. That's a degree of the circle. This is a length of the chord. You could also use that they are equidistant from the center. So somebody with context clues, what does equidistant mean? Equal distance. Okay. So you have this extra line, like this radius from E to H and E to I. So if you know that these pieces are congruent to each other, then you could also say the chords are congruent. So if I know EF equals EG, so if you know that these pieces are congruent, then you could also say the chords are congruent. So basically, everything is like kind of like congruent. Okay. And then the last part is if you have a diameter or a radius that is perpendicular to the chord. Perpendicular means what? Right angle, you have 90 degrees. So if I have my radius that is making a 90-degree angle with the chord, then it's bisecting it. So it bisects the chord. It also bisects the arc. So once again, if I knew the arc around the outside was 100 degrees, if it bisects it, each side would be 50-50. If I knew the length of AB was 10 and it's bisecting it, each little piece would be 5 and 5. So the pieces match. So basically, if EH is perpendicular to AB, then it's cutting it in half. So I could say AF equals FB. And I could also say arc AH equals arc HB. And I know this is kind of like sounds like a lot. You'll see today's is not that bad. In circles, it kind of is like hard, and then it gets easy for a little bit, and then it gets hard, and it's easy for a little bit. So this is one of the easier days. It just seems like a lot. Shh. So we're going to skip a lot on the front. So let's cross out number 1. Let's cross out number 2. Let's cross out number 3, because like, why not? You'll see that these questions are really easy. So we're not going to do a million of the same questions because that's like pointless to us. So let's go to number 4. Well, that's why we're skipping a bunch on the front. So for 4, what am I going to do?
Equal them to each other.
Equal them to each other. So take a second, add 72 to both sides. Subtract 5 to both sides. Nope, because this arc matches this arc. They're congruent. What'd you get, 13? So 13 is not the answer. You got to figure out what you got to find. Mm-hmm. My pen stopped working.
Whatever you do is wrong. It just sent me one.
Yes.
Hey, no spoilers. I think it might be 7.
Wait, 7, yeah, sorry.
Yes. So then you got to find the measure of arc. That's why it's a curve. RS. So you plug it back in. 11 times 13 minus 72 is 71 degrees. Not too bad. Okay. So we're gonna skip a few because like most of them are equal to each other, to be honest. Okay. Let's go to number 5. So take a second, look at number 5. Well, you gotta look at what you got.
It's 6 points.
So add to make what? 360. Now you can't. Shh. The reason why you cannot do 180 is because it's not going through the center of the circle. If you had a diameter like the other problems, you could subtract from 180, but you cannot subtract from 180. So if this is 76, this is 6x minus 20. Where else can 6x minus 20 go? The other side. And then you're adding up everything to make 360 because a full circle makes 360. So you could write out a really long equation, or you could just combine like terms now. So if I combine my x's, 6x and 6x makes how much? 12x. And then I'm adding all my numbers. So I have 76 to start. I'm minusing 20. I'm minusing 20. How much do I have? 36. And then I'm equaling it to a full circle 360. Yeah. Okay, so 27. Do you have to plug it back in? Nope. Okay, try number 6. 6 is ugly, but it's not bad. Because there's, so in these ones, these are just chords with arcs. This is a chord with an arc with a part of the radius. So the pictures, it's okay, don't stress. Put your numbers in your picture. So it's a little ugly. What are you gonna do? Equal them to each other. Because they're both a piece of the radius. And because you know the chords are congruent, if the chords are congruent, then the piece of the radius is also congruent.
So. Oh, I can't remind you of this. Oh, I'm so hungry.
Wait, what?
Yeah, it was. Oh, no.
Did I do something wrong? No, I'm second guessing myself. No, that's correct. So then you're going to take X and you have to plug it back in because you need MP. Easy peasy. Not too bad. We like today's better. Kind of. People don't really like circles. Should get 16. No. Because it's 5 times 10. What are you finding? MP. 5 times 10 is 50. 50 minus 34.
Oh. My God, I was.
Okay, let's skip 7. Let's go to 8. So like I said, we're skipping a lot. Skip 7. Okay, so for number 8, take a second, look at what you got. Aiden, what do you gotta do?
I want, you got the five, the parentheses, those like, yeah, I don't know how to just say it. And then after that, put the self complete.
So wait, what are you doing with them?
You get your plate equals tense.
Okay, but like, what are you doing with these?
Yeah,
Yeah. So do that.
you told me that, but.
No, bless you. So what do you get for X? 19. Okay. And then take a second. You're gonna have to think about, you're trying to find M. Okay, hey, you need to move.
Oh, no.
You can move back whenever I'm done teaching. Let's go back. You have to find MP.
Hey, you're a customer, go in. It doesn't make you cool, by the way.
Oh, I think I'm so good.
Okay, here's the thing.
X is 19.
We do like, we do like. The admin.
Yeah. Yes. No.
Plug it in 19, plug it in for X, and subtract, I didn't subtract from.
So if X is 19, a lot of people will forget to plug it back in. The arc is not 19. You're doing 5 times 19 plus 33.
Wait, is it? Oh.
So how much is that? So 128.
Oh, so you actually get it for.
No, because they're the same.
So you can multiply by 2.
So you could do 128 times 2, and then you're gonna minus from 360.
So then the other thing. Minus 180.
360.
So then what up was?
Okay. Try number 9.
So this is the
M is the measure of arc MP. So try number 9. We're gonna skip in 10.
and he would like 60. That's 1. So then 5.
Try number 9.
It's got to add sound.
How did I get the 104? If this is 128 and this is 128, a full circle makes 360. Meaning the missing piece. So you subtract both of these from 360 and get what's left over, which is 104. Because you have to minus 128 twice.
Oh.
Because I think that doing a million problems of exactly the same type of problem is kind of pointless to you. I don't really want you to have a bunch of homework. You don't understand number 9? Okay. 9. There's no equation. You're just trying to fill in like numbers. You have to remember that chords match each other. And radiuses will bisect the chord and the arc. So take a second, think about it.
It's pretty 18. But if RS is the same thing as that.
Yeah, but it's the whole thing. So RS is 18, the whole thing. So the whole thing is 18. You need
Oh, so you
TB.
divide by. Oh.
Yes.
So the Or 9. And TU is 9.
No, because it's a whole thing.
Oh, sorry. It's W said SP9.
No, because that's an arc. That's why it's got like a curve, because it's the outside of the circle. Yeah. Wait, what did you say? Why you do it? No, because it matches.
So it's not. Oh.
Okay, so let's start going over these. T to V is going to be how much? 9, because the chord is being bisected. T to U, the whole chord is how much?
18.
18, because it's the same as the other chord. W to S is on the first chord, 9. And now you're talking about arc measure, which is the outside of the circle in degrees. So you have Y to U, which is how much? 42, because it matches the other side. The other one wants to know R to S. No, not 36. 84, because it's the whole thing.
Oh.
So you'd have to add 42 twice.
Oh.
Okay, we're skipping 10. Let's skip 11. We're going to do 2 problems. So we're going to do 12 and we're going to do 13. That's it from the front. So take a second, look at 12. Yep, so we're crossing out 14, 15, 16. Like I said on the front, there's no reason to do a million of the same type of questions. You just kind of got to look at what you got. Most of the time they're equal to each other. Take a second, look at 12. Maybe put it on your picture. We're only doing 12 and 13. Do they look equal? No,
You said 156.
you could. No, we're not doing 360
What?
because I don't know enough information. I don't have DE. I also don't have CF, so I can't make 360. I don't know. Not 180 because it doesn't go through the center. It's not like a straight line. Not 90 because it's an arc. No. Beautiful. Because this arc is the whole distance, this one's half of it. So you know that these two are going to match. So you could add this twice and equal to the other side, or you could double it. So 2 times 7x minus 15 equals the other whole arc, which is 12x minus 8. Hayden just cut the other arc in half and then equaled it to the smaller part. But there's a million ways to do these. As long as like your brain's thinking correctly. So we're going to distribute and then solve. Yeah. It doesn't technically matter, but I would add 30 because the 30 is a bigger negative number. What's it? 62. Nice.
Oh,
So we're doing 12 and 13. That's it. So 13 is left. How do we feel? Yeah, this isn't terrible. We've done worse times. What's up? Where I plugged it into? So because I want the measure of C to I, from C to I is this little piece, so I don't have to plug it into the big one. I don't even have to double it. I'm just plugging into the small. 7 times 11 is 77 minus 15. So like you're doing 7 times 11 minus 15. Yeah. Was it? Yeah. Good job. Yeah. 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 Okay, last question. 13. Think about it. No. Not equaling to 90. Yes. So you need to find WV, which is this whole thing. We know the radius bisects it, so we're going to find the little tiny bottom piece, and then we can double it once we do the Pythagorean theorem. Good old Pythagoras, who thought he was gone, but here he is once again. So 13 is C. 13 is your C. Pythagoras. Yeah. Well, thing to say. Well, okay, but that's not the answer.
Oh.
It's not 6. It's 24. Because if the little bottom piece of the triangle is 12, this is also 12, and you need the whole length, so you add them together, so you double it. Okay, so on the front, if we skipped it on the front, you can skip it. You do not have to go back and do those. You can skip them. They are done. I don't want you to do a million problems, okay? On the back, we're gonna skip some as well, because I don't want you to do a million problems. I think this isn't terrible. There's no reason why to like kill ourselves, okay? So let's go to the back. On the back, you can cross off number 14, 16. Where's the other one I crossed off? 10 and 12 and 8. Okay. No, that's it. So on yesterday's paper and the day before, I'm gonna come around and look at those because I was in the media center yesterday, so I can check the last 2 days paper. So I'm looking for 109 and 108. They're both 10.2. So one's 10.2, one's 10.2 classroom. Take those out, have them out. I'm gonna come around.
But it's like, I can't remember.
If it's in the bin, that's fine.
Oh.
Yeah.